Welcome to Ask and Learn.
In this problem on the topic of rotation, we have a long uniform rod which has a length L and a mass m and is pivoted about a horizontal frictionless pin that is passing through one end of the rod. If the rod is released from rest in a vertical position, as we can see in the figure, the instant that the rod is horizontal, we want to find the angular speed, the magnitude of the angular acceleration, the x and y components of the acceleration of the center of mass, as well as the components of the reaction force at the pivot. Now, since only conservative forces act within the system of the rod and the earth, we know that there is no work done due to resistive forces, so delta E is equal to 0, which means that the final kinetic energy plus the final potential energy must equal the initial kinetic energy plus the initial potential energy, so energy is conserved. The final kinetic energy is angular, so that's a half I omega squared plus its initial plus its final potential energy is 0. Its initial kinetic energy is 0 since it starts from rest, and its initial potential energy is gravitational, mg times L over 2. So the moment of inertia here, I, is 1 over 3 ml squared. So therefore we can see that the angular speed, omega, from the equation above is equal to the square root of 3g over L. For part B, we want to find the angular acceleration. Now we know that by Newton's second law for rotational motion, the sum of the torques must equal to I alpha, where alpha is the angular acceleration. So in the horizontal direction, we have the torques mg times L over 2, which is the torque due to the weight, is equal to m L squared over 3 times alpha. So from here we can see that the angular acceleration alpha is equal to 3g over 2L. For part C, we want to find the x and y components of the center of mass acceleration. So the x component, ax, is equal to the radial component of the acceleration, ar, which is minus r omega squared for rotational motion. And this is equal to minus L over 2 times omega squared. But we already know omega, so this is minus 3g over 2. The y component, ay, is the tangential component, at, or minus the tangential component, which is minus r times alpha. And so this is minus alpha times L over 2. And using our expressions above, this is minus 3g over 4. For part D, we want to find the components of the reaction force at the pivot. So we've labeled this reaction force R, and it has components Rx and Ry. The x components of the reaction force Rx is equal to m ax, and this is minus 3 mg over 2, since there's only one force in the horizontal direction, and the force Ry minus the weight of the rod mg must equal to may. So we're using Newton's second law here. And we know this is equal to minus 3 mg over 4, which means that Ry is equal to mg over 4.